When we define space as deflected time, the particles of the Standard Model, the 10 dimensions of string theory, and the rotational anomalies of galaxies all resolve into necessary geometric consequences of this single bending string. When the one-dimensional string is pushed laterally, it opens into a parabola. Radial, azimuthal, and longitudinal coordinates only exist inside this resulting curvature. This diagram shows the baseline state, an undeflected loop, a plane torus called T0. This represents the pure vacuum substrate. The first spatial deflection forces the string to twist, forming a Mobius strip. Pushing the string further causes the path to split into an oval geometry. This second spatial deflection, T2, creates the necessary structure for heavy quarks. The geometry exhausts its spatial options at the third deflection, folding the oval paths into a triangular Y-junction. This T3 structure forms the three-dimensional geometry of protons and neutrons. This toroid hierarchy maps perfectly back to the Minkowski metric. The negative c² tension is the T0 substrate. The three positive spatial dimensions are the successive T1, T2, and T3 deflections opening one by one. In this framework, particles manifest as specific, quantized geometric knots woven into the time string itself. The initial deflection of the string does not produce one time dimension and three spatial dimensions. It produces three distinct time-like dimensions. This diagram displays those components: the left chirality column, Tx, the right chirality column, Ty, and the shared observable substrate, Tz. Because a winding wave requires both a chirality orientation and a spatial axis to exist, the total state space is the tensor product of these axes. Mapping the three time-like variables against the three spatial variables generates 9 coordinate combinations. Adding the undeflected Tz vacuum substrate, the string before any deflection occurs, brings the total count of independent degrees of freedom to exactly 10. These 10 dimensions represent the exhaustive span of all possible winding configurations. Every particle state is a specific subset of this 10-dimensional state space. Quantum mechanics already utilizes this tensor logic in the Dirac equation. To describe matter, Dirac was forced to use this 4-component spinor matrix. The two left chirality Dirac components map to the two spatial spin orientations available inside the Tx column. Similarly, the two right chirality components map to the orientations available in the Ty column. Dirac's 4 components and string theory's 10 dimensions are different projections of the same geometric requirement, an exhaustive list of the ways a string can wind across its available axes. A particle must strictly choose between the left or right chirality column. This animation illustrates why, by tracking the tangent angle of a winding path as it moves inside a parabola. If this geometric wave tries to cross the boundary from the left parabola to the right, the tangent angle hits exactly 90 degrees and mathematically diverges to infinity. Because of this tangent divergence, simultaneous occupancy of both Tx and Ty by a single particle is geometrically impossible. There is one topological exception. When the geometry exhausts its spatial options, it can build an Einstein-Rosen bridge, the T4 structure. This spans the chirality boundary, linking two states. We observe this as quantum entanglement. Quantum entanglement and chirality limits are strict physical boundaries imposed by the tangent limit of the deflecting time string. These geometric limits apply at the macroscopic scale, particularly in extreme fluid dynamics, like a collapsing cavitation bubble or the tip of a tornado funnel. Both systems experience a sudden, extreme mechanical tension spike, concentrated along the vertical z-axis. This vertical pressure violently compresses the Tx and Ty geometries, pushing internal paths past absorption limits, hitting the 90-degree tangent. Failing to absorb the pressure, the geometry bleeds excess curvature tangentially into the observable Tz plane, manifesting as unexpected bursts of electromagnetic radiation. The flashes of light from sonoluminescence and tornado plasmas are macroscopic topological failure points of the time string bleeding into our dimension. At the speed of light, the tension time string behaves as a compressible fluid substrate. Just as moving fluids create low-pressure zones, mass reduces the local tension of the string, causing the higher tension vacuum to push inward. We call this gravity. At galaxy edges, density drops and the inward Venturi pole breaks down at a specific Reynolds number. The flow shifts from inward pressure to a tangential vortex, exactly like a draining bathtub. The fluid no longer falls inward. It orbits at a sustained velocity. This tangential fluid vortex flawlessly predicts the flat rotation curves of galaxies. The galactic halo is not a sphere of invisible particles, but the fluid vortex wall of the time string itself. From the four components of the Dirac equation to the rotation of the darkest galaxies, the universe does not exist inside a space. It is the exact calculable consequence of a single tensioned string deflecting at the speed of light.